Hello, everybody. We are going to wait a few more moments before everybody joins, and we are going to start the webinar. Thanks a lot. Hello, everybody. Welcome to another webinar series. This time it will be about up-to-date post-processors. And this will be part 6. As you know, we already hold the 5 parts so far. It's been a while in the time when we hold the last one. But use this opportunity to make the part 6, as many of you requested that to show us, what are the new things available in SolidCAM 2021 SP4 release. And before I jump into presentation, I would like to show you a couple of things that I really like to do, before each webinar, and is to show you our amazing forum where I invite everybody to visit it and to follow it, to make an account there, and to watch what's the new things about each of the topics. And today what I will show to go to the post processors here, and over here this section you will find something that we're doing and updating very often, is that we always put the things, what is new in upcoming release. Okay, so what are the new features available in the post processors? So if you click on this download link, it will bring you, to this amazing document, where we store every single detail regarding to what's new in the post processor for this release. I hope many of you already seen this. Okay, but even though if you didn't see it, I will try, to make this webinar very interesting, as there are many things that are not really in this document, like in those details that I'm going to show you in this webinar. Right, so let's jump into presentation. And I'll try to go with something that is really basic, but by my opinion, it's extremely good. And the first thing that I want to show in this webinar is that today we can have a complete output control over interpolated forward axis output. And what I mean about that is, over here on the left side, you can see in the interface we have the motion control. And every time, guys, when you want to go with a bar on the mill turn and running with the C-axis with tool orientated like this, and the output is in the XZC. In that case, you can always do it in 2 different ways. It depends of what your machine and controller allows you to do. Some of them have the cycle for Cartesian input. Some of them doesn't have, as this is an optional, and not all the machines have it. Okay, so in the case when your machine doesn't have this function, and like in FANUC, everybody who are familiar with FANUC, it's 12.1. Besides of the Cartesian input of the coordinates, it also allows you to synchronize the linear and rotary axis feeds. Okay, so this is also another great benefit from this axis. But as I said, not all of the machines has it. Okay, and there are also a third group of the machines that it has the 12.1, but the customer still wants to use XZC output straightforward. Okay, no Cartesian output, but the polar output. Okay, and every time when the customer do so, something like this, you need to make sure as a post developer that those 2 checkboxes are turned on in the case you want to receive, correct path. Okay, so you can imagine that square workpiece, and you have the tool goes from this direction to this direction. It has to be interpolated, because receiving 2 points at each end will create concave surface over here, which will not be correct. That's why those things has to be turned on. And of course, in this case, you cannot use the compensation. Okay, So I will show you how to use these two parameters, and they are appearing in the starter job. The second example, I see that many of you ask this, and it's coming very often in the support tickets, is like how we can correctly support the indexed positions on the rotary targets. Okay, so I will in here I will just demonstrate how it was supported in 2020 and earlier versions. So as you know, you basically create additional stations, and this example is the example when we have 10 stations. And in this webinar, I will use this turret at main point, as mostly on the market, on the machines, you can find, the rotary stations, rotary turrets with 12 stations. This is very common. But today I'm going to use the one with 10, okay? And over here we have the 10 that you have defined as default, but also in additional one, between those two, you create additional indexed position. And there were so many downsides. As you know, you need to create a holder with specific angle, or you need to shift everything relative to the station. You can finally do that, everything is okay. You somehow you manage it, everything is nice, but it is not so nice to do it. Now, if you followed some of our previous webinars, you figure it out that we have a new option available in SolidCAM 2021. It's rotary turret interpolation, which basically allows you to define only the main real turrets, okay? Not turrets, sorry, the physical stations. And the indexed position will be the measured orientation that you are going to measure the tool, and that will be your index position. So together with that, of course, you can imagine here that you have 4 index positions for each of the of these stations. So you can imagine that if this can have like 4 stations and you have 10 stations over here and additional 10 stations here, you will get about 400 transformations on the XML data. Okay, so be aware of that. So the last thing is about easier tool management. I think it's much easier when you have the list of 10 only, the real one, connected everything within the one tool assembly, that's for sure much easier to do. And today I'm going to use this example as a new variable, a measured orientation. As you can see it over here, that it comes out in the def tool, turn def tool, change turn tool, and start a job, and how we are going to use it, in getting, correct tool call on our machine. So let's jump into SolidCAM. Okay. And in this case, I have one very complicated machine. It is about M32 4th generation M8. Okay, for all of you who are familiar, great. Who are not, I'll try to a little bit bring you closer this machine, because I'm going to use this in this demonstration. So everything what you see over here, it's called like a gank tool post, and this is basically a channel 1. Okay. The lower turret itself, everything what you do on the lower turret, it will come out like channel 2. Okay. And here we have the back tool post over here, and this is actually channel 3. Okay, so with that said, let me just rotate it over here. This revolver is 10 stations, okay, and it has the index positions. It starts from 20 number, okay. A reason for it, it's, I guess, machine manufacturer wanted because it's from the second channel, so that's why it starts from number 2, okay. And everything that it's indexed, it is basically the index difference is 20 over here. Okay. So enough for this saying. What you see here, it's very simple part that I will use in this demonstration. And the reason why I'm showing you this one, it's my very first part before I test any switch type. I kind of very like it. It's very simple to do it and to test, the whole stuff very easily. And in this case, I'll just use over here this job just to see where we are. and I just make the turn over here, okay? And I want in this demonstration to use the C-axis, just interpolate over this bar, nothing so special, just to get some toolpath. I want to show you the example, and for this I'm going to use this tool over here. But before I do that, I will probably have a collision once it approaches, so I need to make sure that the turret is in retract position. So I'm just going to quickly do that in the home reference. Great. And I'm going to create a simple profile operation just to get some kind of toolpath. Here it is. I like it. I'll just reverse it. I'll go just exit C. I'll go to my tool and try to find it. As it is on my revolver, I'll try to find my revolver. I will go to my preview. I can see it's on 29. I can just move it to the right side so it's pretty visible. I go to 29. Okay, so as you can see, here's the holder. And I have two tools here. And this example, I will use this tool over here. So I'll just click on the anvil. And that's it. I'm just going to accept it. Perfect. I will use my second submachine, as this is for the Z2. I want to move the Z2, not the Z1. So I'll just save and calculate. Let me see if the preview is correct. Flawlessly. Exactly what I wanted to do. Right. Now, one more detail before we jump into posts is that I am going to use the fourth axis, in this case polar. Okay, so if it's a polar, I want to, let's say like this, if it's a polar, I want to use x, z, c straight coordinates, and when it's the Cartesian, I want to use the G12.1 cycle. And the mission for this is, when I'm using this one, I just want to make sure that user switch these two checkboxes correctly. Okay, so this will be the example over here. So I'll just leave the job. Probably have to copy it. I'll just jump to my post. I'll generate the G code. So just let me see what I have here. I have some error message. Okay. So as you can see, even though that I'm using the polar, you go back here. Even if I'm using the polar interpolation by distance and everything, this is turned off, I still get some toolpath. But if I go with this G code on the machine, I will get crash on the pod for sure. Okay, so it will not come as this for sure. So what I'm going to do, I am going to open the post, and usually where I'm turning on and off 12.1, it's in my line 5 axis procedure. Okay, and I know that many of you don't know this post. Okay, so don't even try to understand everything. But what is important in this webinar is that you see these lines of code. It simply says that every time it's the phase, please turn on the phase interpolation. So the one here that you see, it means output 12.1. While if it's 0, it will turn off the 12.1, which is usually coming in the move 5 axis. Right. So we want to implement those features. So what I'm going to do, I will just insert a few lines of the code. So first, I will check what is the output type. So if rod axis coordinate equal axis for Cartesian, yes, please, sir, give me these lines of the code. So I'll just indent it a little bit. And if it's not, if it's a polar, please, I'll just copy this data, okay? And instead, I will use opposite, okay? So I will just remove this data here. And I'll go with X oppose. I do have the oppose, and between I can put, the apose. Okay, so I guess that every one of you, whoever implemented this, this is nothing so strange. Okay, so pretty okay. And here I just want to implement something more. So no problem at all. Let me go to my trace. This is how I usually teach everybody, you know, don't try to remember all the variables, but don't be lazy. Go to your trace, you know, and you will find it there. So start your job. And at the very end of the procedure, you will find approximate interpolation for distance. So make sure that, you know, the interpolation for distance doesn't give you the value, but it's rather 0 or 1. So 1 is if checkbox is used, and 0 if it's not used. While arc approximate, you really get the value. Okay, so pay attention that this is like a numeric, while this one is integer. So I'll just copy. And here in the else, I'll just put the condition if arc approximate not equal 0, okay? Or let's say if equal, or then we need to, you know, error. And it's very simple one, so I don't want to go into details. You can, of course, do it further, okay? And if, yes. So that's basically it. Now with this, I'm pretty sure that customer has to use this. So let me try without it. Generate the G code. I didn't get it because if it's equal 0, it's okay. If it's Cartesian, if it's polar arc approximate, did I miss something? Let me see. Yeah, I didn't save it. Okay, crazy. All right, so let me try. Okay, so here's the error, and I'll just click OK. And I didn't write it, of course, correct. There is two here. Okay, so but you got the point. Okay, so now if the customer is using it, I can generate the G code and click OK. Nice. So as you can see here, we are not receiving any 12.1, pretty much straight opposed coordinates, and everything is so nice. Okay. Now you are sure that the customer will not make any crashes or on real toolpad over there. So this is the first thing. So let's go with further. Okay. I'll just jump again back to this job. Okay. So I want to show you how to implement index position. Okay. So what I'm going to do first is I will use this end below here, okay? I'll just click on this and pay attention that measured orientation here, it is checked, but it's now currently set to 0. So if I open my machine preview and I go over here, and if I click on my cutting point, you will see that this cutting point here is on 0 position. It's not really measured, okay? So if I try to use this tool and 7 calculated, you will note that there is no enough stroke over the y-axis and complete target become red, and y2 axis it's marked there that hey, there's not enough stroke to finish this. So you need to do something, right? Let's go back to our tool. I will go to the cutting point, and now this is a little bit of small details. What will be the index angle? Now on every machine you have to do it differently, okay? So you will save this data, per turret. There are one ways how to do it. Also, the folder shows everything by itself. So you can go to the measurement, you can click there, click here, and you'll get here the angle of 18, okay? Of course, you can calculate it differently as there are 10 stations, 360, full circle divided by 10 is 36. And index positions is just divided by 2, and you will get again 18. But be aware that it's not all the turrets have it really on the middle. I've seen many that it's not really in the middle, so pay attention on that as well, okay? So in this case, I will going to put 18. I know it's not the correct one. As you can see here, rotated to the wrong position. So from turret to turret, you need to put correct value. So in this case, I'll just put 18. So in the case it's 18, it will be my 49 tool. If is positive 18, it will be my 48. So the delta for this, sorry, for this one, it's 19. For this will be 20. You probably agree with that. Right, so let's implement that in the code. So I'll just use this. Let's see now the preview. As you can see, automatically SolidCAM recognized this. It looks beautiful. It looks exactly what I wanted. Nice. I'll just say calculate and just generate the G code. I'll go with the trace file. And I will try to find measure orientation, and you can see variable over here. So I'll just take it. And what I want to do here, guys, so let me go back to my program. As you can see here, my tool code is 29, even though my tool over here should be 49, right? So how to make this correct? The offset is 29. That's probably okay. And let me see, actually, I didn't check this. The offset for this one, I'll just use 79. So just user-defined offset 79, but my tool should be 49. Okay, so how to do this? I think it's pretty simple where I think you also see where I will go. So I'll just go to the procedure where you have a change tool. Again, you don't need to remember, and analyze the whole code, really not necessary, but as you can see, the whole stuff over here is not so long. And the most important, parameter for this machine is just tool position in turret. And this is how it is calculated. And later, just I have the tool call that will really just print out this, okay? So what I need to make sure that I have the delta added to this variable in order to, whether or not I will add this 19 or 20 in the code, okay? So let me show you how I'm going to do that. So first, I'll just put, my local integer, and I'll just call it like, I don't know, like indexed position, okay? And my tool position turret will be tool position plus substation, whatever the substation is, I don't know. And I'll just add, indexed position to it, but I need to calculate the index position, okay? So I'm going to do it in the code over here, okay? So a little bit more space. As the turret itself, as I mentioned also in the beginning of this webinar, it's like 2 channels only. Sorry, 3 channels, but the Revolver is on a second channel. So I'm going to use that as my information. So I'll just use to channel ID when it's equal to, okay? And I have index position will be something. Else, I'll just make sure that my index position is 0. This is how I'm starting with writing. And then I'm going to add more things. Okay, as I said also before, I want to make sure that my turret, it's really measured on 18 degrees. So you can prevent user by giving him an error message while he will generate a G code that, hey, something is wrong. The measured orientation is not really 18. So you need to do something and fix it in your toolkit, okay? So in that case, I'll just use the absolute function. It will include the plus and minus 18 degrees, okay? And if absolute orientation not equal 18, okay? So if it's not 18, then we are going to print error message like something like this, okay? And else, if it is, we are going to calculate it. So we are going to say my index position is now based on, is it a positive or negative? Okay, so we are going to say, again, if measured orientation equal minus 18, okay, we can do it like this, then is the delta, it's 20. And then we can say else if measured orientation equal 18, we can say that this will be 19 of index, okay? That's it. So As you can see, with all of this, a little bit of line of code, we are going to test it right now. I never write the code the same time all the time. Okay, so it's always something different. But we are going to make sure that this line of code works fine. Okay, so let's go to post, and I'll just generate the G code. Just perfect. Look, we have a tool called 49, and also my offset is 79. Just great. So let's just jump in my tool, and I'm just going to test this error code. So I'll just put some crazy number here and generate the code. Hey, measure orientation is not. So it looks and works great, guys. Okay, so this is how you can easily now support the indexed rotary turrets without any problems. Okay, so I got a lot of questions on this, and this is so simple to do it today in SP4 that I hope that every post with rotary turrets will have, and that has these index positions, will have something similar in their codes. Okay, right. So let's go back to the presentation. The next topic is extremely interesting, and really one of the things that one of the greatest change in and let's say feature that we called subtool. Okay, it is a capability of each turret. Okay, and by default I say it's set to no, and here it is where it is in the VMID. But now with simply words, I will use what this parameter is. So in the case, I will talk like universally. Okay, it's not really connected to some controller, even though some controllers will require it, some not. But basically, it allows you to have different tool number for each counter in one tool assembly. As you can see here in the example, I just put 2 tools in one assembly. And as you know, today, if you try these 2 tools have the same tool number, they have the same tool ID. And if you want to have it different, then this requires an option. This is an option on the machine. For example, on Siemens, it's called the multi-tool. If this is allowed, it will allow user and operator to define 2 different tool numbers or tool IDs on one assembly. Okay. There are a couple of here slides, so we'll go through and you will understand it. So let me go further. So it will allow using different tool IDs for each cutter. So each of the cutters can have different tool ID. Also, it resets the tool offset index. And also, by default, it is set to no. So none of the post processors available today, they don't have set this to yes. Okay, nothing before SP4. Okay, just after the SP4, you will have this as an option. Okay. Just bear in mind that this option will not be visible for you up until you go to beta options in your SolidCAM settings and allow with the checkbox there. Okay, I think this is also important to say. So before I just jump to what is happening to yes, let me just say how we are handling these kind of stuffs today. Okay, so today, if I want to support these kind of things, when I say multi-cutter tool item, no. I'm talking at the most about panel controllers, about Mazak controllers, okay, with matrix and SmoothX. These machines doesn't, at most, as I said, at most doesn't require, to have a multi-cutter tool item set to yes, but to no, okay. So in this example, I'm just showing you a simple example. I have my left tool, which is tool number 0101, and my right tool is 20111. 01 is the station number, and 11 is the offset number. For most of you, I believe that you know this. Now, as this is a station number, in post processors, I often see, and this is absolutely correct, people use the tool position in turret. It is completely incorrect if you are using, the tool number in this case, okay? So tool position in turret, and you will find its ID over here. For the offset number, there are two different versions or options how you can support this. And it really depends from customer to customer and sometimes from machine to machine. And I will not stand, to only one side. I will just show you both ways how it can be done, and you decide which one is better for you. And I'll just tell you my experiences. So every time when the customer knows that my tool, I only have, for example, 2 tools maximum per my turret, per my station, sorry, it means that my offset for main spindle will be from 1 to 10, but for my back spindle will be from 11 to 20. In that case, I will definitely use my tool offset index as A, B, C, D. In this case, it will be only up to B. And tool position variable can be used. Here I leave the asterisk symbol, as I have pretty nice formula how you can calculate the offset number by tool position in turret plus the tool position multiplied by 10 minus 10. This 10 is the number of the stations. It is always constant. It's based on the turret itself, okay? So if I want to get this output, so my tool station in turret, it's 1 plus tool position. Let's imagine that I'm using B, which will give me the value of 2 multiplied by 10 minus 10. So 1 plus 20, 21 minus 10, it's 11. This is the value that I will receive. So you can imagine 3. Okay, no problem. So 30 minus 10 is 20 plus 1 is, so you will get here 21, right? So 30 minus 10 plus 1, and so on. So you can use this formula in this case. But for those, and I prefer this way, and on this M32, I did it that way, because customer said that doesn't have the strict rule how he's naming here. Sometimes it can be 2 tools, sometimes 3 tools. Pardon. I prefer that I always use the tool offset index of A, while the customer needs to define the custom tool offset number, okay? And in this case, you are going to use the D offset for your turning jobs and tool offset number for your milling jobs. Everybody who make the post probably knows about this, and this is by default. And if for all of you who are watching this and you're not familiar with these things, I think you'll find this slide very useful. Right, and now let's get to things when we set particular turret with a multi-cutter tool item to be yes. I split this to a revolver and to the spindle, and in this case, I will take the example when I calling my tool with a tool ID. Okay, so I call my cutter by cutter ID 1, and here also cutter 2 over here. So machine automatically knows that if you call the cutter tool, machine knows that it's on station 1 and is this cutting point over here. Okay, now each of these cutting points can have many more than one cutting point, and how we can support that. Okay, so that's what is all about the multi-cutter tool item. So if you have 2 different tool numbers or tool IDs, we are going to reset the tool offset index. So for each of these, you can define D1, D2, D3, and everybody who knows the Siemens, they will find themselves, that this is extremely useful. Each of these cutter can have D1 up to, I think, D9. It depends also of parameter and also machine manufacturer. And for this cutter, it also can go from the D1 to the D9. It's about the number of the cutting points. And you can define up to 9 for each cutter, okay? But also to make it clear, this option of having it yes, it's not really connected to a controller. For example, Siemens, even though you have a Siemens, it's still the multi-tool, it's an optional. So only if you have this option to yes, you can use it, okay? Right, so with that said, here I just left here cutter ID for 1 and 2. You will use the tool ID for the variable tool ID string. While for the D offset number, you can use the same variables as we mentioned in the previous slide, pretty much the same, okay? Either tool position or D offset and tool offset number. Right, now for the spindle type, nothing's changed too much. You have the cutter 1, you have the cutter 2, you have the cutter 3. That's great. And for each one of these, you can change, the offset index. We're going to see how this looks actually in the software. And this is an example how it actually really looks on the controller itself. And over here we have the location. The 5 over here that you see, guys, here is the magazine just number. This is the tool number, okay, or the socket on the machine. And you need to declare that on 11 socket we have a multi-tool. In this case, 6 different tools, and for each we can define its ID. Okay, so first number, then the ID, and at the end the offset, D1 and D2. So I will not go too much about the subtool and how to define it, what are the rules and so, but just the bare minimum, because Sir Michal Wieniawski will also have upcoming webinars about it, and he will speak at most about it. And here I will just give you the basics, okay? So let me just show you how toolkit behaves when you don't have this set to yes, okay? So again, I would just, I just mentioned this, but I just want to show you, if you go here to miscellaneous, you have here the better options. And here you will see, allow subtools. So it has to be checked. Bear in mind that in the upcoming hotfixes, this will be completely removed, so you will not need to allow it. But just in case, if you don't see this option, it is over here. Right. Let's go to the toolkit. And I want to use an example of on the back tool post. I have here one interesting turret. This turret itself, it's 3 positions only, 31, 34, and 37. On each of these positions, you can attach these kind of holders that you can see in front of yourself, guys, and each of them can have 3 different tools, and each tool is called differently. So 31, 32, 33, then 40, 34, 35, 36, then 37, 38, and 39. Okay, now let's go with that. I will just try to find this 31 here. Here you go. And we have here 2 anvils. Right. Now, I will just in this case create another anvil. I'll just copy this one and paste it. Let's see what I have. Great, I like it. Just let's put something more real. Great. As you can see, each one of these, if I go to the quick axis, each one of these have the same ID offset index, okay, and the tool number. So if I try to go to another one, everything will be the same except of the offset, okay, because we have no enough tool offset index. The offset will be automatically switched, okay, and also for the third one, as you can see, it's switched. That's great. So how to add the subtool? I'll just go to my holder. You can go to any element, but in this case, it is the most realistically that you go to the holder itself. And here you have an option of adding a subtool. So I'll just add subtool, and this is for my subtool 1. So I'll just do a drag and drop. I'll just add another one. I'll just do drag and drop, and I'll just do add a subtool and drag and drop. Just to let you know, there is no differences if this parameter multi-cutter tool item is set to no. There is no differences whether you are adding the subtool or not adding the subtool. Okay, so there's no absolutely differences. So you can see that even though that I go to each of these subtools, everything that you can see here remains the same. Nothing's changed. Okay, so what I'm going to do now, I'll just go and edit my post. So I'll go to my back tool, and I'm going to change my multi-cutter tool item to yes. Right, and with that, let's go, and be more Siemens controller for a moment, and I'll just go to my index table, and I'll just put like D1, D2, and D3. Okay, and in my back tool, I'll just say that my maximum is set to D3. I'll just leave it, and I'll go back again to my tools. Right, here it is. Here we are, guys. Nothing's changed, okay? As you can see, except that we are increasing the tool index. Why? Because each of these has equal same tool number and tool ID, all right? But what will happen if I do something like this? I say 32, and I'll call this my cutter 1. I will go and I'll call this cutter 2. And over here, I will just say 33, my cutter 3. That's great. And as you can see now, I have D1. I can have again D1, and I can have again D1. Please bear in mind that here I will just need to put 32 on the offset and also 32 on the offset. Okay, 33 in this case, sorry. Okay, so this is, I hope you get an idea what the subtools are, what is the power within, okay? And let me just repeat it. Only if it's allowed on the machines, okay? Now you have all the power to support it. All right. Let's go back to the presentation. A couple of more slides, guys. The next topic is, I would say, okay. The next slide over here is about something that we want to make sure that all our customers that are coming, with the parts defined in SolidCAM 2020 and earlier, and when they open the things in 2021 SP4, they have received all the cutting points and tools correctly converted from their parts, and they can generate a G code and not afraid that something gets wrong, okay? It looks a little bit difficult chart, but I'll make sure that we go slowly with this, and I will explain you each one of these, how it is, and you'll see that it's very logical what I will say. So imagine that you have one part defined in SolidCAM 2020, okay? And you want to load it in 2021, okay? We don't still know how many jobs or something. You don't know what are the tools there. And so what SolidCAM will do for you is the following. So the first thing what we are checking is, and this is by, the only way to support correct convert of the cutting points is that we look not only on the CAM part, not only on the VMID, but also the GPP file, what it is used in that case, all right? So the very first thing what we're checking, if the user tool offset exists in your GPP file, okay? We are checking if it is existing. So I'll go to the left over here, and let's imagine that, yes, there is user tool offset defined there. There is in the text, okay? So we are going to search then if my CAM part has user-defined offsets. A little big flashback, guys. In 2020 version, we had in our jobs, we have this checkbox, and the user was able completely freely to define diameter and length offset in the job itself, okay? Right, so if the customer don't use in his CAM part, the offsets here, so there is no jobs with this, then every tool will have only one single cutting point. It will be converted like that, where the offset number will be equal to the tool number, okay? This case over here. But if somebody used this checkbox, then it will be generate one tool with multiple cutting points. Okay, so how that looks like. So let's imagine this is an example, where we have only two jobs, guys. Okay, we have two jobs, both are using the same tool number. In this case, tool number 1. And we have a first job. In the first job, we are using, the user-defined offsets as it is defined over here. So on the first job, offsets like this, where this is tool number 1. We have diameter offset 10 and length offset number 100. Okay. Then we have a second job where we don't use the user-defined offset. The convert result will be that we have only one tool, one cutter with a tool number 1, but with 3 cutting points. Cutting point 1 with offset number 1, cutting point 2 with offset number 10, and cutting point 3 with offset number 100. Right. I hope that makes sense a lot. Now let's go back again here. So again, we are searching, the user tool offset if it exists. So in the case when it doesn't exist, so if we are not using this, what are the examples? The example is, that my H&D use the variable, the tool number. Okay, so we don't use it like that, okay? Or maybe we are using the D offset or H offset. Okay, so if it's not, the next checking is if we are using the D offset or H offset. No, we are not using it. Okay, no problem. Then every cutter will be, you know, generated over here. And if we are checking, how we are checking this, guys, okay? So here are a couple of examples of how you are defining. So even if you're using it as an equation, or it is in the square brackets, or like anything that you can see here will be detected as that you are using the D or H offset, okay? Now, in the case that you have here and they are in semicolon, which means it's not used, then it will not be detected, okay? So if it is detected that we are having some of these, we are checking the new VMID parameter that it's called, it is in the working style toolkit. And here we will see, you know, the convert H and D offset as a single cutting point, you will have yes or no. So you need to make, you know, if the customer really wants to convert this as a single cutting point, here you have a, you know, control, and giving him back this VMID, he will be able to, you know, go into details how his CAM parts will be converted. So even though, oops, like that. So if it's yes, it will go to a single. If it's no, it will, you know, generate single cutting with the multiple cutting points. A little bit strange, but a little bit big chart, okay, guys. But the point of this slide is just to let you know that we really care about all our parts and our posts in the past, and we really want to make sure that there are minimum efforts that customer needs to change, maybe, you know, or to change nothing. That's our goal, okay? And we are showing you here now how to do it, you know. In this particular case, cutter cutting points. And at the end, I left something very nice. Let me go back to this. And the last feature that I want to show you guys, it's really brilliant, a really new XML structure for a machine simulation. I know that most of you were waiting for this, and it is now available in SP4, okay? And the case study for today is the same citizen that I said earlier, okay? And I will compare the XML output in the past and today. I'll show you the advantages and disadvantages. Generating the XML structure in the news version, you just need to open, you know, the new SolidCAM, and the procedure is the same. Right click on in the VMID, you know, export to XML, everything is there. You have nothing to do more, okay? So let's jump into this. So on the left side, you can see the structure of the earlier version of the SP4, okay? And you probably remember this, guys. So if you have the turret, then if you have, like, for each station, you have 4 different index positions, then for each will be generated transforms. So there was a lot of transforms, okay? So it really influenced to the loading speed of the machine simulation and also on the performance, okay? On the right side, what you can see is the new structure. As you can see, it almost looks like our VMID, nothing too much about it. There's just the stations, there are the ID of the turrets, also the stations, and it looks like this. How we are distinguished if it's a new or old structure is by this SolidCAM data here transform. The name is very critical, okay? It will be automatically generated, you don't need to worry about it, but that's the way how we are figuring out, is it a new XML structure or the old XML structure? Right. So the very first advantage is that it's a lot reduced and simplified transformations, okay? When I say this, you can imagine that over here, it was always a problem, let's say let me just jump. I wanted to say something, but it's actually in this second. So we eliminated the limits with the numbers of used cutters in tool assembly. In the previous versions, we always ask and we make sure that customer is happy with the maximum number of the cutters, okay? And sometimes it was 2 cutters, sometimes 4, you know, it depends, you know. But if you have 2 or 3 turrets, you know, then you need to be very careful with this number because it really affects the machine simulation performance, okay? And with the toolkit, In the toolkit, as you know, guys, you can create assembly with 100 tools. You have no limits. So how we can make that? And not to mention, about the collision detection and stuff, how it can be handled. The only way is that we create a new, completely new stations, which will be replaced by the number of tools that are available during the machine simulation activation. So we will, if you have 100 tools over the station 1, we will replace it over here, okay? So today with the new structure, we have no limits in the number of used cutters. That's great, okay? The third is, we are automatically adding the target stock 3, 4, and band X in the case of the multi-channel machines. Everybody who creates this, he knows that when the user use the add a new workpiece, okay, it is necessary to have 3 or 4 elements of this target stock stuff if you want to use the machine simulation, okay. So today that's actually coming automatically. It definitely simplifies the collision definition and its performance, okay? I'll show you the next slide how much, but you can just imagine how, and you remember probably how frustrated it was to define number. It depends on the number of transformations, but each transformation has to be included, each tool, each holder and stuff, okay? And the last thing here that my opinion, it's I think the most important, it reduced the loading time of the machine simulation dramatically. And here at the bottom here, I just left. Once you export, the XML data in previous version, it was 220 kilobytes for this particular machine, while in 2021 SP4, it's only 18 kilobytes here. You just can compare it. It's just amazing saving, in the size and performance for sure. And the last slide over here is how the collision are defined. As you can see on the left here, look at this slider here. It is enormous how many elements you have here, okay? It takes time to define it. But on the right side, look, everything what you can see here, that's it. Only the station you mounted, and that's it. Everything that will be later through the toolkit and SolidCAM mounted to that particular station will be included in collision detection, okay? Right, guys, I hope that was it, okay? I hope you really enjoyed this webinar. There will be more, okay? We have a few more sales and technical ones in ahead, but I can just to let you know that there will be part 7, part 8. There are a lot of questions on the forum. Please keep, posting the questions there. And for the end, I'll just leave one detail here. We have a new topic here that you can find. It's called tips and tricks. And guys, don't be lazy. So in the case when you are logged in this case I'm not, but here you will appear, the button of subscribe. It will allow you to subscribe, and every time when there is something new topic here, you will get information over your email. Okay, so this is a new topic that I really like. So there is the topic about post-processor tips and tricks. And as bonus, today, here we are adding a lot of stuff, okay? But later in this week, I will just place here a little bit of code to support, the helical that are bigger than 360 degrees. I found that this is coming pretty often, in the support. So for the controllers that are with limited of memory, okay, and a lot of helical approaches on the pod, this can be really memory saving. And I'll put the code, how you can put it on every post, okay, and support it. All right, with that said, guys, I hope you enjoyed, and see you in the next webinars. Thanks for watching, and see you next time. Bye-bye.